This is another lecture in the FOA series about fiber optics and premises cabling, because this one applies to both. Here we're going to be talking about optical LANs, OLANs. We've had several conversations recently with people in the industry who've been around for a long time. And we're beginning to wonder why we build local area networks in 2012 using 1982 phone technology. Let me show you what we're talking about. In 1982, the typical office had multi-line phones where every line had a pair of copper conductors carrying what we call a POTS signal, P-O-T-S. Plain old telephone service, and offices were full of copper cables and punch-down blocks. We were just seeing the first of PCs used and the first portable PCs. I remember lugging one of these compact portables home from the office every day in spite of the fact it weighed 30 pounds. We stored data on 5¼ inch floppy disks, and when computer networks existed, mainly for mini computers, they used Ethernet, using large coaxial cable and what we call a vampire tap. That year, AT&T, concerned with what was going to happen when they changed over from analog or POTS telephones to digital phones and digital PBXs, did a survey of their customers. They wanted to know what the architecture for a phone system should be. They surveyed a total of 79 businesses in California, New York, Florida, and Arkansas. Arkansas? Those customers had 10,000 phones on desktops total. That's about 100 per customer. But what they found was that practically all of these phones were less than 300 feet. That's about 100 meters from the telecom closet. And 90% were less than 50 meters or 150 feet. This became a very important survey for later use. By 1989, large companies were starting to network their PCs. They were still using primarily Ethernet, although there was a little token ring still around. But it had moved from thick net to thin net using BNC connectors and smaller coaxial cabling to the new UTP cabling networks based on twisted pair, which was developed from phone wire. The problem is all twisted pair wasn't equal. So Annixter, the largest distributor of this cabling, established a laboratory and began testing and grading UTP cables, creating their levels program. That became the basis of structured cabling standards. So, in 1991, we saw the release of the first generation of TIA 568, a standard for structured cabling. This standard was based on that 1982 AT&T survey. So the cable lengths were maxed out at 300 feet, about 100 meters, and were primarily based on UTP copper. There was a little mention of fiber optics, but no coax, and what we had was basically an architecture based on that 1982 survey. Internationally, this didn't become a standard until ISO established it in 1995. The 1990s was a very active era for structured cabling. Distributors and designers of networks and contractors installing it all spent a lot of time and money learning what structured cabling was all about. By the time we got to the year 2000, lots of people knew what it was going on, were trained in it, and they were ready for a new generation of standards that added fiber optics. in the form of centralized cabling. Centralized cabling basically allowed multi-mode optical fiber to be used to expand the size of a standard structured cabling network. Otherwise, looks just like 1982. In the roughly 3 decades of local area network history, Ethernet has become the dominant protocol, and speeds have increased from 2 megabits per second in the late 1970s to 100 gigabits per second today. As the speeds of the networks have increased, the cabling and the cabling architecture has struggled to maintain the same pace of development. So during that same time period, that 30 years, we've seen roughly 10 generations of copper cabling. From Ethernet ThickNet through ThinNet, ungraded UTP, Level 3 UTP, and then what we call Cat 3, Cat 4, Cat 5, Cat 5e, Cat 6, Cat 6a, ISO Class F, which never became a US standard because it's Cat 7, augmented Cat 6, and now we're even considering Cat 8. Think about it. 10 generations of copper. How many systems have been built, obsoleted, and replaced in that time frame? In that same time frame, we've had 4 generations of optical fiber. The first LANs were built with 100/140 fiber, a large core fiber that was abandoned because it required a different size connector. And everybody went to 62.5 fiber for 15 years. When gigabit Ethernet came along in 2000, there was a movement to 51/25 fiber, laser optimized to give faster speeds with the new VCSEL lasers, the inexpensive lasers used for gigabit, 10 gigabit, and faster networks. Now we're seeing a movement to single mode fiber, and we'll see that in a second. In that time frame, we've had 100 different fiber optic connectors. Fortunately, only 4 of them were widely used. Today, our local area networks have changed remarkably. Most of our devices have gone mobile. They connect to the network wirelessly. Wi-Fi is required for all LANs, and many buildings, especially large public buildings, have cellular data inside available through distributed antenna systems, just like outside. Few users want a cabled LAN anymore. They're mainly people who still work with desktop computers and particularly large amounts of data, like CAD/CAM or graphics, or engineering, where they need very fast connections. But our typical LAN architecture still looks the same as 1982. We use our basic POTS telephone system based structured cabling system, and we add wireless access points cabled into local switches, or maybe we'll use centralized fiber with media converters at the desktop. Is it time for a change? Should we continue using 30-year-old POTS networks to support multi-gigabit LANs? Is it worth trying to make UTP copper faster? Or even multi-mode fiber? We're up against bandwidth limits with multi-mode fiber now. Why do computer networks ignore what outside plant telecom networks have evolved into, taking fiber straight to the home? Are we just avoiding change? Well, not everybody is. On a trip to the Middle East, we met with Cliff Walker, who designed the new local area network for the Emirates terminal at the Dubai airport. Airports are special conditions and typically use fiber anyway because of the large distances involved. But Cliff decided to use technology like a point-to-point fiber-to-the-home system with small special switches connected on single-mode fiber to a central facility that offered multiple outputs for PCs on Ethernet, voice-over IP phones, wireless LAN access points, and IP-based cameras. Cliff calls this fiber to the office, and it's a very good name. It's basically a point-to-point network based on single-mode fiber that connects small switches in local areas over single-mode fiber back to a central facility. It's essentially the same as point-to-point fiber to the home. And because fiber to the home now has millions and millions of people connected over fiber, the cost of those components has become very reasonable. So here's a network that uses a new architecture, a simple architecture, has no intermediate electronics. It's just nothing but passive fiber from the computer room to the local switch. Here's another way of doing basically the same thing using a slightly different technology, using passive optical network technology used in fiber to the home. This is a network at the San Diego Central Library, which is currently under construction. The network was designed by Tellabs based on their equipment that uses the same basic hardware you'd have in fiber to the home in a PON system. But in this system, instead of lots of copper wire, you're actually running a single fiber out to a work area, a switch, and connecting up 4 users. So the total of 4,000 network access points requires only 1,000 single fiber, single mode cables. Here is a block diagram of the optical LAN or passive optical LAN used in applications like the San Diego Public Library. It's exactly the same block diagram of a fiber to the home PON network which has tens of millions of users around the world. The big advantage of a PON is you can share some of the expensive electronics among as many as 32 to 64 different users, cutting the cost even further. These two methods of building optical LANs, or OLANs as we call them, are really quite similar in architecture, but are implemented somewhat differently. Fiber to the office uses Ethernet on single-mode fiber and is an active link. It uses small local switches at the work area, and those switches, which require power, of course, can provide power over Ethernet powering devices to devices like voice-over IP phones or wireless access points. It doesn't need telecom closets, doesn't need much of anything except some passive connects. The passive optical LAN is very similar. It's just like a fiber to the home PON. It provides very, very high capacity in a small space. All it requires for hardware is places to put the PON splitters needed in the network. Another interesting thing about passive optical LANs is because of the optical splitter, the same signal is broadcast to all users, so it's encrypted. And that's one of the reasons, the encryption, that this is very popular among government agencies. All optical LANs, or OLANs, share some common traits. They use single-mode fiber with no bandwidth limitations, or for that matter, practically no distance limitations. So they're equally applicable to a single building, a large campus, or even an airport. They take advantage of the technology and the economics of fiber to the home. They are simpler and cheaper to install. terminate one single mode fiber instead of masses of UTP copper. It avoids all the UTP copper that is required by a traditional structured cabling network and all its associated hardware, like cable trays, patch panels, telecom rooms, local switches, and the like. But it connects to all of our devices over standard UTP patch cords. It doesn't need media converters because that's part of the switches that we use in the local area. It's designed from the outset to accommodate voice, data, and video, or anything else that can run over Ethernet. And it's about as future-proof as you can get. Here's an interesting comparison that shows you the difference in the installation of an OLAN versus structured cabling. A large structured cabling network is going to look like the picture on the left, with masses of UTP cable running in cable trays and having to be dispersed to numerous areas in the building. Whereas each of those work areas only needs a single fiber optic cable, a tiny little cable about 3 millimeters in diameter to service the same area. So that's an OLAN. It's a LAN that uses modern technology, not 30-year-old technology. It's actually lower cost than structured cabling, and by that I mean for a single wall outlet. It's shown in time after again that the lower cost of the electronics and the lower cost of the cabling are genuine. It still connects the devices with UTP patch cords, and of course that includes wireless access points. But right now the standards groups are playing catch up when it comes to OLANs. They don't know quite how to fit it into their networks. But the telephone company people have all their standards internationally for fiber to the home, and they look just like what we're talking about with these optical LANs. For more information on fiber optics, premises cabling, and optical LANs, you can go to the FOA website, where our online reference guide will give you hundreds of pages of technical information, and our FiberU website provides self-study programs for those wishing to learn more. We're the FOA, the Professional Society of Fiber Optics.